Welcome to qnawire.
Binding energy is the energy involved when the nuclear particles, the protons and neutrons, come together to make a nucleus. And this energy has to do with another concept called mass defect. Mass defect is symbolized delta M. You would expect if you added up the masses of the protons and neutrons, it should equal the total mass of the nucleus. But in fact, there's usually a difference between the masses. And so this is what the mass defect is. Mass defect is related to energy by Einstein's equation, E equals the change in mass times the speed of light squared. And so the binding energy comes from this difference in mass. We can measure the mass in atomic mass units, and its relationship between atomic mass units and energy is that 1 AMU is equivalent to 931.5 mega electron volts. A mega electron volt is equal to 10 to the 6 electron volts. And electron volts are related to joules. 1 electron volt is 1.602 times 10 to the minus 19 joules. So if we have a given isotope, we can find the overall binding energy by finding the mass defect and then converting it. If we have, for example, an oxygen-16 isotope, we know that that has 8 protons, because that's the atomic number, and 8 neutrons, because it's the mass minus the number of neutrons. And so the oxygen atom should be 8 times the mass of a proton plus 8 times the mass of an individual neutron. The mass of a proton is 1.007825 AMUs, and the mass of a neutron is 1.008665. So in atomic mass units, this isotope of oxygen should have a mass of 16.13192 AMU. But we know that the actual mass of this nucleus is 15.994915 AMU. So our mass defect is the difference between the two. Or 0.137005 AMU. To find out this equivalency in energy by using the conversions that we discussed at the beginning. I can change it to mega electron volts. By multiplying by 931.5. And that tells me that for every nucleus, I should produce 127.6 mega electron volts per atom. And so this is the binding energy per atom. If I want to talk about the binding energy of a nucleon, I remember that there are 8 protons and 8 neutrons, so there are a total of 16 nucleons. So my binding energy per nucleon is 127.6 mega electron volts divided by 16, or 7.976 mega electron volts per nucleon. And finally, if I find it in units kilojoules per mole, I know that it's 127.6 mega electron volts per atom, and that there are 6.02 times 10 to the 23rd atoms per mole. And there are 1 times 10 to the 6th electron volts per mega electron volt. And there are 1.602 times 10 to the minus 19 joules per electron volt. And finally, every kilojoule is equal to 1,000 joules. So if I multiply 127.6 times 6.02 times 10 to the 23rd times 1 times 10 to the 6th times 1.602 times 10 to the minus 19 divided by 1,000, I find the energy is 1.231 times 10 to the 10 kilojoules per mole. That's the binding energy.